Hello, I'm Stefan Schneider from Paderborn University, and I'm going to present our demo on cloud-native threat detection and containment for smart manufacturing. So this work was done in the 5G Tango project. It has been presented as one of the pilot use cases at the end of the project. And I worked on this together with colleagues from Paderborn University and from Weidmüller. I'm not sure if you know Weidmüller. They are a pretty large-scale manufacturer from Germany, but with factories worldwide with long experience. And as you can see, even Obama and Merkel know them. So I had the pleasure of working with them together towards this smart manufacturing and factory of the future use case. And the situation that we have in our smart manufacturing scenario is that we have manufacturing machines running in a factory producing parts, and they're all connected, and we're collecting data from these machines about sensors, about the produced parts, and we can use this data for analysis in order to verify if everything is okay, and also to optimize our manufacturing process. So all this has been done previously. We published it, and we built there on the 5G Tango service platform, and we developed containers to connect these different machines and collect their data. So in this demo today, I want to focus on ensuring that everything keeps running as smoothly as it is. So for that, we first of all need to monitor our machines in production to see what is going on. And if there is any kind of problem, we want to make sure that we can detect these problems automatically. So specifically here, we want to detect possible intrusions by an attacker that might want to access our machine data or even add own malicious data. And in case we detected such a problem, then we want to resolve these problems automatically. In this case, it means we want to isolate the intruded machine. These goals, of course, come with their own set of challenges. Clearly, we need real-time monitoring. We also need a cloud-native intrusion detection system that we can deploy with our other services. We need flexible reconfiguration of services and of our cloud-native network functions in order to react to possible intrusions. And this whole threat detection and isolation should be fully automated. So let's have a look at the high-level architecture, which you can see here on the left side, where you see the core components and the main data flow. And this flow starts at the bottom here from the manufacturing machine, which produces parts and which is connected using EuroMap 63 to the network service 2, which is our machine interconnection service that is deployed once per machine. That service collects the data, converts it, and sends it using MQTT to the network service 1, which is our factory edge service that's deployed once per factory. And there, all the data from the different machines is collected, can be visualized, and is sent to the cloud. Now, in case we do have an intrusion at one of these machines, first of all, we want to ensure that no malicious data is sent to this network service 1, where it's combined with data from other machines and then sent into the cloud. But at the same time, we also do not want to just throw our data away, because we might need it to analyze what is going on, to debug the situation, to resolve the problem. Or maybe it's just a false alarm, and we might want to have the data after all. And so what we do instead is that we have our IDS system that detects an intrusion, and once that happens, we reconfigure network service 2 to no longer send the data to the normal network service 1 that's used in production, but to a second isolated instance of network service 1 that we call the quarantine network service 1. And there the data is isolated, the threat is contained, but the data is still available for analysis. And just let me highlight this. In current factories, what would happen is that staff would have to manually notice that something is wrong, that there is some anomaly. They would have to call a technician to come over, pull the plug, and at that point, no more data or nothing would be available at all. It would take a long time. So this is a really big improvement over what we currently have at factories. So let's have a look at the details. Here we have the machine data arriving from the left to the network service 2 through the IDS to our machine data collector, which is part of network service 2. And there it's sent usually into the network service 1, the production instance. Now, in order to realize this flexible and automated detection of threats and reconfiguration, we built on the 5G Tango service platform, where multiple advanced components play together. So let's see how this works step by step. In case we do have an intrusion, this intrusion is detected directly here at the IDS system. The IDS system sets an IDS alarm metric, which is picked up by our monitoring system, by the monitoring manager. At this monitoring manager, we have rules installed to react to that alarm, that trigger an alarm and send it to the policy manager. Again, here we have a policy installed that at runtime reacts to this alarm trigger and knows that we have to reconfigure our network service 2. So it sends a reconfiguration trigger to our service-specific manager. So this is custom code that we developed that knows, okay, in order to reconfigure network service 2, I really need to reconfigure this machine data collector. So the reconfiguration is sent to the function-specific manager of the MDC, and there the reconfiguration is really executed such that the data is then sent no longer into production, but into the network service 1, the quarantine instance. Yeah, so let's finally come to the demo. Let's see how this works in practice. The starting point is that both the normal and so the production and the quarantine network service 1 instance are running. We also have network service 2 running. The machine is connected and it's producing parts and sending data. And at some point we simulate an intrusion by an attacker. This intrusion gets noticed by our IDS system, which sends an alert, and then ultimately network service 2 is reconfigured to send the data into the quarantine. And with that, the threat is detected and isolated. So this is the starting point. You can see here the analytics dashboard on the left side of the normal production network service 1, where the data arrives from the connected machine as it should. And on the right side, the quarantine network service 1, where no data arrives because there has been no intrusion so far. So that changes now. We now have an attacker that we assume is already inside our factory network. The attacker already knows the IP address of our network service 2, maybe from some kind of previous hack, and is now scanning for open ports at this IP address. And indeed, there are 2 open ports that are being used by the Euromap 63 protocol. So the attacker now wants to use this in order to connect to the Samba share that is being used in order to get access to the machine data, or maybe even in order to add own malicious data. So we're currently here at the point that an intrusion happened, and our IDS system detects this intrusion. We can see that by having a look at the dashboard of our IDS system. Here we have a list of all intrusions, and yes, the intrusion that just happened was detected. It's down here. We also have additional information about the username, for example, of the attacker and other things that might help us here. So we're at the point that the IDS system detected the intrusion, and it's now setting an IDS alarm metric that is picked up by the monitoring system. So here in our Prometheus monitoring, you can see that we have 3 different rules installed. One is for this IDS use case. You can see that it now changes from green to yellow to red as this IDS system, IDS alarm metric is being picked up. And with that, the monitoring manager sends the alarm trigger, and this whole reconfiguration is being executed until the network service 2 is reconfigured to no longer send data into the normal network service 1. So you can see that no more data arrives here, and instead the data is now being sent to the quarantine network service 1. Yeah, and with that, the threat is detected, the data is isolated, the threat is contained, and that was a success. Just briefly, an alternative to this automatic reconfiguration is manual isolation and de-isolation. So if someone at the factory notices an anomaly, it's also possible to trigger this isolation through the factory management portal just by clicking a button. And once the problem is resolved, to de-isolate the machine by clicking the de-isolate button. We implemented this on top of our whole reconfiguration loop just by using a command and control server that forwards this reconfiguration to the service-specific lifecycle manager. From there, the same loop is executed as before. Yeah, so that brings us to the conclusion. You saw that we do support real-time monitoring of production machines. We do support automatic intrusion detection, automatic reconfiguration, and machine isolation. And we also saw this alternative of manual isolation and de-isolation through the portal. And this all helps ensure uninterrupted and secure production. and that means reduced risks and reduced costs for manufacturers. So if you're interested, have a look at our open source repository. You can find all code, all containers, and detailed walkthroughs there. So have a look. Thanks.